solving some puzzles, I guess. So our trig identities, we've got our reciprocal identities, and you should already know those. The Pythagorean identities, there's 3 of those, and really this comes from, you probably know this one too, sine of squared x plus cosine squared of x equals 1. And if you think about the unit circle, and we talked about the standard form of a circle is just x minus h plus y squared plus y minus k squared equals the radius squared. Well, if my unit circle has a center at 0, 0 and a radius of 1, and remember that sine squared, or sine, is my y value and cosine is my x value, then there's my x squared plus y squared equals 1. I don't know if that made any sense or not, but we'll go with it. So let's just suppose, let's take this same identity and divide everything by sine squared. Well, what would I have? I would have, that's 1. That we know is cotangent, so we've got 1 plus cotangent squared equals, and that's the reciprocal of cosecant squared, so that would just be that. Alright, so there's another one. And then I'm going to do the last one. I'm going to do the same thing, except this time I'm going to divide all 3 terms by cosine squared. And then we know that that is tangent squared. That's 1. And the reciprocal of that is secant. Alright, so I actually should have put my 3 right there, because there are my 3 Pythagorean identities. And the reason I did it out like that was really, if you know that one, you can come up with the other 2, or you should be able to come up with the other 2 just by doing what I just did there. Okay, and then even in odd identities, they'll come in handy here and there. So just know that, I don't know if you remember how to find or determine whether a function is even or odd, but when you plug in a negative x and get the opposite out, it's odd. And when you plug in a negative x and get the same function out, the original function out, it's even. So in this case, sine and tangent are odd functions, and cosine is an even function. Okay, so these are just, all these are just going to be helpful in order to do what we've got to do with chapter 7. Alright, so let's come up with, let's just go ahead and do some examples. I actually wanted to do this first. So, like I said, it's pretty much a puzzle. You're just trying to manipulate one side or the other, or both sides, until you can verify the identity or simplify it, or whatever they're asking you to do. This isn't set in stone. It doesn't always work, but in general, if I'm doing these, the first thing I'm going to do is I'm going to try to write everything in terms of sine and cosine. And that pretty much takes care of everything. And then if I see something squared, if I see a trig function squared, then I'm going to be looking to my Pythagorean identities to simplify it. So, like I said, the reciprocal identities and the Pythagorean identities especially, you need to be very familiar with those. Alright, so let's just go ahead and do some examples here. We've got, this is number 4, we're in section 7.1. So we've got, all it says to do in this particular section is write everything in terms of sine and cosine and simplify it. So if I'm looking at 4 and I've got cosine of t times the cosecant of t, all I'm doing is writing this in terms of sine and cosine. Well, cosine is cosine, and then cosecant is the reciprocal of sine, And then when notice I put that over 1 just because when I multiply fractions I go straight across. So I've got the cosine of t over the sine of t, and I know that reciprocal identity is the cotangent of t. That's easy enough. Alright, so let's do another one. So the secant of x, if I write that in terms of sine and cosine, that's going to be 1 over the cosine of x. All over, the reciprocal of that is 1 over the sine of x. And then I'm just going to use my rule for dividing fractions because this is fraction bar and I'm dividing. So this is going to be 1 over the cosine of x times the reciprocal. And when I multiply straight across again, I get the sine of x over the cosine of x, which I know is the tangent of x. Okay? Just going to keep going. Writing everything in terms of sine and cosine. The cotangent is cosine, cosine over sine. And cosecant is 1 over sine. And look what I did. I changed that. It doesn't matter what symbol. So we're using theta, x. It doesn't matter. Alright, so we've got 1 over sine minus the sine of theta. Alright, so what are we going to do here? You have two choices. And I'm going to probably just go with the easiest thing to do, how to handle this. So if I've got a complex fraction, and this is what this is, right? I've got a fraction and a fraction. The easiest thing to do, unless it's one fraction over one fraction and you just flip and multiply like we did in this example where we just flipped and multiplied, basically if I have more than one term in the numerator or the denominator, the easiest thing is to multiply every term by the common denominator of the whole thing. Now if I'm looking at this whole thing, I see that I've got sine of theta as one of my denominators, and then I've got sine of theta as a denominator down here. So my common denominator is the sine of theta. So if I multiply everything by the sine of theta, when I say everything, I mean every term in this complex fraction. Alright, when I multiply that out, notice that those signs are going to cancel out, and that's going to leave me with cosine theta up top. And then on the bottom, the same thing's going to happen with that term. I'm going to be left with 1. And then here, you've got to be careful because those aren't canceling out. This is a numerator and this is a numerator, so that's just going to be 1 minus sine squared of theta. Alright, so here we go. This is where you've got to look at this and think, can I simplify this any further? Well, the cosine of theta is simplified as much as I want to do anything with that right now, but here is where I say if you see something squared, you need to be paying attention to your Pythagorean identity and thinking, can I simplify this anymore? Well, remember that if sine squared plus cosine squared equals 1, if I subtract sine squared from both sides, that means that cosine squared is going to equal 1 minus sine squared. Well, that's what I'm looking at right there. I'm looking at 1 minus sine squared, which I can simplify or write that as cosine squared theta. So really this whole thing is cosine squared theta, cosine of theta over cosine squared theta, and I know that I've got 1 that I can cancel with one of those on the bottom, and that's going to leave me with 1 over the cosine of theta. And I'm running out of room here, but you know that the reciprocal of 1 over cosine theta is the secant of theta. Okay? I hope I'm not out of time yet. I'm going to try to get a couple more in here. Alright, let's see. Notice I'm just continuing like I was. I'm writing everything in terms of cosine and sine, and then I'm going to clean it up. Alright, so I'm multiplying reciprocals. Well, we know that's 1. And now I've got 1 over, cosine, I keep messing up, over sine. Alright, so I've got a complex fraction. So I flip and multiply. And sine over cosine is the tangent of x. Okay, I kind of messed that up. I hope you can follow that. Alright, one more before I stop this one. So here I'm looking at sine to the fourth, sine x to the fourth minus cosine x to the fourth plus cosine squared of x. So I want to kind of break this down and figure out how I can rewrite this into something that I know how to simplify. So immediately I'm looking at these two terms and thinking I can factor those because this is the difference of two perfect squares. So let's go ahead and write that. And you would factor that just like you would x squared minus 4. It's x plus 2, x minus 2, the difference of squares. This is going to be sine squared of x. This is going to be the cosine squared of x. And my signs are going to be opposite. Okay? So that's that broken down, and then I've still got plus that cosine squared of x. Well, ding ding ding, I'm looking at something squared here, and I have a Pythagorean identity that tells me that sine squared of x plus the cosine of square of x is 1. So that whole thing simplifying to 1. And then I'm just going to leave that. I can't rewrite that as 1 because my identity is sine squared plus cosine squared. So this is just going to stay sine squared x minus cosine squared x times 1, and I could have just gone ahead and gotten rid of my parentheses in that last step, but I didn't. And notice now I have opposites, and those add out. So all I'm left with here is the sine squared.